Hello friends! One of the things I really enjoy about software engineering is system design. So this is something that I'm really passionate about inside software engineering, and not only system design but high scalability, distributed systems, and everything related to scaling and to distributed systems as well. And that's why I brought to you guys in this video today, and we're going to read the blog of Pinterest, and we're going to see how did they evolve their whole architecture and how they start from serving 0 requests until tens of thousands of requests inside a single month. And that's the high scalability blog. So they have this section here for Pinterest, and they say scaling Pinterest from 0 to tens of billions of page views in a month. So that's billions of page views in a month. That's extremely large amount of requests and page views for any website to handle. So they say that Pinterest has been rising an exponential growth curve, doubling every month and a half. They've gone from 0 to tens of billions page views in a month in 2 years. So during the period of 2 years, they simply got from 0 to that number, that crazy number of page views. From 2 founders and 1 engine to over 40 engineers, from 1 little MySQL server to 180 web engines, 240 API engines, 88 MySQL databases, and then they describe here the kind of instance they are using: CC2 8x large, that's an EC2 instance for Amazon Web Services, plus 1 slave each, 110 Redis instances and 200 Memcached instances. So they just started from 0 up to this crazy and large infrastructure to handle that crazy kind of load that they have. And one interesting thing here is that at the beginning, as they probably didn't know what they were doing, they started really small. They started 2 co-founders and 1 engineer, and then they started from that point on. They did not try to tackle or to foresee anything. They were just going through whatever problems they had at that point in time and adapting the systems accordingly. The number one here is the architecture is done the right thing when growth can be handled by adding more of the same stuff. You want to be able to scale by throwing money at the problem, which means throwing more boxes or more resources at the problem as we need them. If your architecture can do that, then you're golden. What they are basically saying here is about the scalability of the system, and more specifically is to scale out the system. That means if we have 1 single instance here, 1 small web server handling, and if you get more loads that single web server cannot handle, if our architecture is done right, we can simply duplicate that service or duplicate that server, and now we have 2 instances serving all the requests. So that's the horizontal scalability, and that is exactly what he says about throwing more money at the problem, which means simply to create more instances and create more web servers or creating more databases, and then that's gonna solve the problem. Second point here is when you push something to the limit, all technologies fail in their special way. This is something very important that they stated here, because we cannot forget that they have this huge or humongous amount of data and amount of requests per month. Probably they tried a bunch of different stuff and they failed, so they had to fix and adapt to that kind of situation. So this lead them to evaluate tools choice with a preference for tools that are mature, really good and simple, well known and liked, well supported, consistently good performers, failure free as possible, free of charge. Using this criteria, they selected MySQL, Solr, Memcached, and Redis. So Cassandra and Mongo were dropped because they felt those technologies were not good at that moment for them. And one interesting thing here on this second paragraph here, or this second point, is that they faced a problem that nobody or just a few other companies had, and they had to deal with that, and they dealt on the best possible way. They were pragmatic on their thought process, and they chose all of these features and all of these tools that had these capabilities or these characteristics they wanted, which are well-known, well-supported, free, they were mature, which means there are lots of support on the market. We can go to any forum and there will probably be someone willing to help, and besides that, someone that had the same kind of problem. That was really good. That was a great choice they had, and they discarded Cassandra and MongoDB because these are NoSQL databases, and they did not feel those two databases would fit them at that point in time. What Pinterest is, so they just give us a quick overview. So the basics are pins are images with a collection of their bits of information, which means a description of what it makes important to the user and link back to where they found it. Pinterest is a social network. You can follow people and boards. And database, they have users who have boards and boards have pins. Follow and repeat relationships, authentication, and information. So that's basically the way they structured that social network. I have an example here. I just signed up with a test account, and this is what Pinterest is. The user can upload images and add that metadata, as I said, such as a title, and we have comments. One user can follow other user. The same user can have a board with lots of pins and that kind of stuff. Yeah, they had to adjust their system accordingly to all the usage that they had throughout time. And that is what we're going to see right now, which is the timeline from when they started until where they found out that was a good platform at the point that they kind of finished their experimentations and their trials. So they launched in March 2010, and they call it as the age of finding yourself. At this point, you don't even know what product you are going to build. You have ideas, so you are iterating and changing things quickly. So you end up with a lot of strange little MySQL queries you would never do in real life. I know how the feeling is. And the numbers, this early date was they had 2 founders, which is the point where they started. 1 engineer. They were using Rackspace, which is a kind of mini cloud provider at that time. They had 1 small web engine, which means 1 single instance or a small web server serving the requests, and 1 small database. So they started really small and they tried to take one step by another step. So in January 2011, they still on stealth mode, and the product is evolving from user feedback. So they launched it 2010 and they let the users play around, and they kept collecting those feedbacks from their users. And the numbers at that time were they were now using Amazon EC2 as the provider for their virtual machines, S3 as a blob storage, and CloudFront that is an edge to serve their CDNs. So all images they could cache on the CDN. They also had 1 Nginx, 4 web engines, that's the web servers, 1 MySQL database, 1 read and 1 slave, 1 task queue, 2 task processors, 1 MongoDB for counters. Now they have added MongoDB on the database landscape, and now they have 2 engineers. So they doubled the engineer count from 1 to 2. And yeah, just a good advancement. Now the third step here was through September 2011, where they call the age of experimentation. And this part here is extremely interesting because they said that they went on a crazy run where they were doubling every month and a half. So every month and a half they were doubling their size. So it was an insane growth. They said when you are growing that fast, everything breaks every night and every week. And that's totally right. So imagine things are going bigger and bigger, and you try to hire more people to help solve the problem, but you still need to train that people, and those people, they will try to make changes along with the existing engineers, and yeah, things will get really weird sometimes. And they said that at this point, you read a lot of papers, white papers that says just add a box and then you are done, which is not exactly like that. So in theory, just throwing more money or adding more boxes so would solve the problem, but it's not usually the way it works. So they started added a lot of technology to help them to solve the problem, and they all break, or they broke everything on the scenario. As a result, they end up with the following architecture. They were still using Amazon EC2, S3, and CloudFront. They are now having 2 Nginx, 16 web engines and 2 API engines, 5 functionally sharded MySQL databases, plus 9 read slaves, 4 Cassandra nodes. Now they also added Cassandra to their landscape, 15 mem-based nodes in 3 separate clusters, 8 mem-cached nodes, 10 Redis nodes, 3 task routers, plus 4 task processors, 4 Elasticsearch nodes, plus 3 MongoDB clusters, and now they have 3 engineers. So they grew a lot and they added 1 more engineer to the roster, which is quite interesting because they were really experimenting and doing different things and trying to solve their problems. They said that 5 major technologies for just their data alone. So as you guys can see, they had this huge amount of data, so they were trying to deal with that problem, experimenting using different technologies. So they were growing so fast that MySQL was hot and all the other technologies were being pushed to the limits. When you push something to the limit, all these technologies fail in their own special way, as they said previously. It started dropping technology and asking themselves what they really wanted to be, because they had all of these things, but they are not quite sure about what they really want to build and all the tools they wanted to have. And lastly here, they said that they did a massive re-architecture of everything that they had at that point in time. They simply stopped and started analyzing their landscape and that technology, their infra, and they realized, okay, we need to redesign this whole thing because what we have right now just took us so far. So we cannot proceed and we cannot go further with what we have. Then they came up to January 2012, where they call the age of maturity. After everything was re-architected, the system now looks like they're still using Amazon EC2, S3, and Akamai. Akamai is probably another CDN or an edge location, plus an Elastic Load Balancer, that's still AWS. Now they have 90 web engines plus 50 API engines, 66 MySQL databases on M1X Large, that's another EC2 instance type, plus 1 slave each, 59 Redis instances, 51 mem-cached instances, 1 Redis task managers, plus 25 task processors, 1 sharded Solar, and 6 engineers. Now they simply doubled the number of engineers they have. Now on a sharded MySQL, Redis, mem-cached, and Solar, that's it. The advantage is it is really simple and mature technology. So they really found the balance on these very well-known and established technologies. October 12 of 2012, they call it as Age of Return, about 4 times where they were in January, so they grew even more. And now the numbers look like they're still using Amazon EC2, S3, Edgecast, Akamai, and Level 3, 180 web engines plus 24 API engines, 88 MySQL databases. Now they are using another instance type class, which is CC2 8x large, plus 1 slave for each one of them, 110 Redis instances, 200 mem-cached instances, 4 Redis task manager, plus 80 task processors, sharded Solar, 40 engineers and growing. So they, from 6 engineers in the last iteration, they just ended up with 40 engineers on the age of the return, as they call. The last step here that I'm gonna read is that they say, notes that the architecture is doing the right thing. So which means all the design, all the architecture and the infrastructure needs to do the right thing. And the right thing is what the product is supposed to be doing, not what any engineer or anyone else wants it to be. Growth is by adding more of the same stuff, which is exactly what they have achieved here in the age of maturity and age of return. They simply kept adding more of the same kind of machines and the same services, and that is pretty good and pretty enough to serve the requests. You want to be able to scale by throwing money at the problem. You want to just be able to throw more boxes at the problem as you need them. And now moving to SSDs, because that's gonna give them way more speed than they had at that time using HDs. The interesting thing here is that they stress out that architecture must be done on the right way. So which means start small, start from scratch, get the requirements, get the feedback from the user, and keep evolving the system. Do not hard code stuff, and whenever there is some kind of entanglement or some kind of spaghetti, and things are not good enough. Those technologies, they are preventing us to advance and to build the systems that we need. We need to stop at that time and re-architect and redesign everything. So it is really nice lesson here that we have learned, and this article is from 2013. So as you guys may have noted, so they started here in 2010 and they finished here around 2000 and end of 2012 and beginning of 2013. So they had this 3-year span where they went from zero until they could serve tens of billions of pages. And all of those things that they have stated here, they are still pretty much hot, and they're still pretty much alive nowadays. So all this sharding, the way to distribute the systems using task queues, Solr and text search engines, and yeah, everything looks pretty much the same as at that time. So I hope you guys have enjoyed my video. Please do not forget to like my video, subscribe to my channel, and also click on the notification bell so you won't miss any of my videos. And I see you guys on the next time.